We're going to be asked to factor these two binomials, and factoring really means turn something into a multiplication problem. A little bit of background, however, something you already know how to do is the distributive property, and so we're going to ultimately undo the distributive property. So let's first start off by just performing the distributive property so it's in the front of your mind. 6 multiplied by 3 is 18, and 6 multiplied by negative w is negative 6w. When I'm asked to factor 18 minus 6w, I'm going to be going backwards, so that right there is my answer. Okay, in this one here, if I distributed the 9 through, 9 multiplied by y is 9y, and 9 multiplied by 2 is 18. But if I'm asked to factor 9y plus 18, that's going to be 9 times y plus 2. So knowing that we're undoing the distributive property, I'm going to show you how you can do this as well by expanding if you get stuck because you're multiplication facts. But in this particular case, you're just asking yourself, what is in common before and after the minus sign? So I'm going to put a minus sign here and a set of parentheses, and we want to take out whatever's in common. So in other words, what's the biggest number that fits into 18 and 6? Well, 6 fits into 6 and 6 fits into 18. So there is a 6 in common to both of these. When it comes to variables, they don't both have w's, so there's not a w in common. So you put a set of parentheses with a minus, and then you write the 6 out front, and then you're thinking, what's left over? Now, if you're multiplying, the opposite is division. So 18 divided by 6, what's left over is 3. 6w divided by 6, what's left over is w. Okay, so in this one, if I want to factor it, I'm going to immediately put a set of parentheses with a plus sign in this one, and I'm thinking, what's in common before and after the plus sign? Well, the biggest number that fits into both 9 and 18 is the number 9. And undoing multiplication is division, so what's left over? 9y divided by 9 is y, and 18 divided by 9 is 2. It's always a good idea to redistribute in your mind just to verify. So if I go 9 times y, I get back to 9y, and 9 times 2 is 18. I haven't done one like this, but if this was just the number 9 sitting here and I took out a 9, that doesn't mean that 0 is left over. There would be 1 left over because I'd need a 1 sitting here to have 9 times 1 get me back to 9. Okay, then this is what it amounts to, but if you are struggling, here's a little longer way to do it, but methodical, is if I want to factor this, I know that I'm going to immediately put down here a set of parentheses with the minus. But another strategy is to expand the 18 and expand the 6w. So to expand the 18, I could come over and make myself a factor tree. And 18 is made out of 2 times 9. Now 2 is a prime number, so I'm just going to bring that one down. 3 times 3 is 9. So I'm going to turn that 9 into 3 times 3. And I'm going to rewrite. I'm going to rewrite the 18 as 2 times 3 times 3 that I got in my factor tree. The 6, if I break that down, that is 2 multiplied by 3. So I'm going to rewrite the 6w as 2 times 3 times W. Now I'm going to look for what's in common to both. So notice before and after the minus sign, I have a 2 in common, and I also have a 3 in common. There's nothing else in common to both, so what I'm taking out front is the 2 times 3, and what's left over is this 3 and this W. And so my final answer then, 2 times 3 is 6, and then I have 3 minus W. So worst case, you can expand this, look for what's the same and put it out in front of the parentheses, and then write down what's left over inside the parentheses.